Sorry. Hello students, today I am going to explain about the difference between heat and temperature. Between heat and temperature. Okay, in our daily life, we interchange these terms. Suppose in daily life we use sometimes heat and sometimes the temperature. Instead of heat, we use temperature also. Okay, for common people, there is no difference between heat and temperature. But for science people, there is a lot of difference between heat and temperature. So, especially when you are studying physics or chemistry, you should be careful about the meanings of heat and temperature. Therefore, today I am going to give a small video presentation to explain about the difference between heat and temperature. So anyway, in the first slide itself, I have given the meanings of heat and temperature. Here I have shown that heat is equal to total energy of the given amount of water. So heat is nothing but total energy of the water. What is temperature? Temperature is average energy of the each water particle. Average energy of the each water particle. Simply, I want to say that you consider water is equal to set of many number of particles. Usually, the particles are in random motion. Random motion means they go in different directions. Okay, there is no particular direction. That is the movement, the motion that is in different directions is called random motion. Okay, I am going to next slide. Okay. Suppose if you consider absolute temperature of minus 273 centigrade, that is also equal to 0 kelvins, then water particles remain at rest. But if you take any temperature greater than minus 273 centigrade, the water particles will be in random motion. Okay, at room temperature of 300 centigrade, 30 centigrade, the water particles are in very vigorous random motion. Okay, such motion we can see only by through powerful electron microscopes. Okay, when water particles are vibrating or when the water particles are in motion, the water particles will have energy, because kinetic energy will come whenever a particle is moving, because kinetic energy formula is of mv square. Okay, similarly the particle will have potential energy. How potential energy will come? Whenever particle positions change, when the position of the particle will change or when the configuration of the system changes, then you will find potential energy. Therefore, when the particles are in motion, the particles will have kinetic energy and potential energy. The sum of kinetic energy and potential energy is called total energy of the particle. To understand potential energy, you can consider bow. When you extend the string of bow, the bow will have sufficient energy to fire the arrow. The reason is, when you extend the bow string, you are changing configuration of the bow. Therefore, the bow with change in configuration is going to acquire energy called potential energy. Okay, let us go to another slide. Now you consider, so as water particles in random motion, they will have kinetic energy and potential energy. Now consider Arctic Ocean. In the Arctic Ocean, Arctic Ocean is very cool ocean. There will be no waves, sea waves at all. The water is standstill water, you can see in the Arctic Ocean. I have given photo also. But in the Arctic Ocean, you will find many water molecules or water particles. As ocean is very cool, the energy of the each particle is very small. Yeah, why? Because the particles are moving very slowly, very slowly. Therefore, there are no sea waves, only standstill water. The water particles are moving very slowly. Therefore, the particles have a very low kinetic energy, low potential energy. Therefore, total energy of the each particle is very low, very small. But there are many number of water particles, very large number of water particles, but each particle has very small energy. If we add all energies of all the water particles, the energy will be very high. That energy is called heat energy. See, heat energy is nothing but total energy of the all the particles, whereas temperature is energy of the one particle. But here in the Arctic Ocean, energy of the one particle is very small, but total energy of the Arctic Ocean is very large, because there are many number of water particles in the Arctic Ocean. Now let us see that this is Arctic Ocean. There are no sea waves, anything, only standstill water. At many places you will see floating ice. Okay, now you consider a bowl containing some water, and if you heat the bowl to the 100 centigrade, the water begins to dance. Water begins to dance. So the energy of the particle, energy of the each water particle is very large when there is a boiling water in the bowl. Therefore, temperature of the water is in a bowl is very large. But there are a small number of water particles in the bowl. When you compare it with water particles of Arctic Ocean. If you compare it to water particles of Arctic Ocean, the number of particles in the bowl is very small. Therefore, total energy of the boiling water of bowl is very small compared to total energy of the Arctic Ocean. Therefore, heat energy stored in the Arctic Ocean is very large, but temperature is very small. Okay, the final conclusion is temperature is very high in the boiling water of bowl compared to Arctic Ocean, but total heat is very small in the bowl of boiling water compared to Arctic Ocean. See, all the difference is because temperature means energy of the one particle, heat means total energy of the all particles. Now come to Arctic Ocean. Here in the Arctic Ocean, temperature is very small in the Arctic Ocean compared to boiling water, because each particle in the Arctic Ocean moves very slowly. Therefore, each particle of the Arctic Ocean has very small kinetic energy and potential energy. What about total energy? The total energy of the Arctic Ocean is very large compared to boiling water of the bowl, because there are many number of water molecules in the Arctic Ocean compared to bowl, boiling water of bowl. Okay. Even though each particle of Arctic Ocean is having very small energy, when you add all energies of all the water particles present in the Arctic Ocean, that number is very much larger than the total energy of all the water molecules of bowl. Okay, this is what I want to say. I think the video has given you a clear idea about what is temperature and what is heat with respect to science. I conclude now. Thank you.